Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and Seth's brother Joel. We are here to hopefully show you how to approach how to do SAT math questions and also how to approach studying for the SAT. Very important. One way to approach studying for the SAT is to sign up to a College Board and get free practice through Khan Academy. Khan Academy partners with the SAT people, and they've broken up the post-2016 SAT into about 40 topics, and they have 20 questions per topic, and we are going through most of these questions, particularly on the upper levels. Circle theorem, we are starting with question 11, and we'll see. If it's very easy, maybe we'll do a few today. Okay, let's circle theorems. We want to re-emphasize circle theorems because this is a little bit of geometry, and it's possible that you have forgotten your geometry by the time you're taking the SAT. So here we go. Geometry circle question. Please read it, pause it, and come back. The sector of a circle shown at left has a center O. The radius of the circular sector is 10, and the area is 75. Oh yeah, this is not that easy. What is the length of the arc? The area is 75. There's no pi in this thing? Wow. And it's a no calculator section? Figure not drawn to scale? Oh, I guess the pi's all cancel. Okay, so I guess we should do maybe we'll do it the straightforward way. If the area is pi r squared, and the area is given to you as 75, then the other way to do it is a quarter of a circle. The other way to do it is quarter of a circle. Oh, that maybe that's the way to do it. If the area, wait. What's that doing? The radius of the circular sector is 10, and the area is 75. What is the length of the arc? Well, they're not telling you that's a 90 degrees section, but the length of the arc is 2 pi r to the whole circle times the fraction of the circle. Where's that 75? Right. Okay, let's do it just the straight way.
Sure. Let me write it out. I'll just write out what the mathematician mind comes up with.
Okay, go ahead.
Here we go. Okay, here we go. Let's see. The area equals 75. And the area is also equal to pi times 10, which is r squared.
Yep.
Times the unknown angle.
Right.
Right? Okay?
Right.
And so you could figure out theta from this.
Right, that's
and
the
then
ratio.
The answer.
That's the ratio of the circle.
The answer is the radius times that angle, which is 10 times theta. So you have to figure out so what you need to figure out from the data that's known what 10 times theta is. Right?
Right.
So that's easy because you could say 10 times theta equals 75, and then you bring the other junk over to the left. Well, the pi's cancel.
Yep.
The 2 doesn't cancel. So you say 2 times here. And then this 10 squared, you could bring another, remove a 10, put it under here, and I think therefore declare as your answer, 75 times 2 divided by 10. 75 times 2 divided by 10 is 150 divided by 10, also known as 15.
Right. Okay, that's great. Yeah. So in the end, I was going off the bad track here. This made no sense. This was the correct track to go. Seth did it through the formulas. You have to figure out what fraction of a circle the area of 75 is. That's the theta thing.
That's not it's the fraction of the circle is the theta divided by 2 pi.
That's right. Exactly. And then that is the same fraction of then the full circumference, which is 2 pi r, which is 20 pi. Yeah. So once you figure out what that fraction is, you multiply by 20 pi, but the pi's cancel. So you get the answer.
Yeah. And what I used was the fact that the circumference is 2 pi r. But I also know that the meaning of radian measure of a circle, when you use radians, and theta is in radians,
right?
Then the length of the arc is the magnitude of the angle times the radius.
The only problem is we need to go through the all the circle theorems, but
I didn't use a circle theorem. I used I used only one circle theorem. The one circle theorem that I used is that the area of the circle is equal to pi times the radius squared.
No, I have to disagree with you.
And then this is the only circle theorem, and then I used that the length of an arc is equal to the angle of the arc in radians times the radius, and then I also use the fraction, that the fraction of the area, and indeed the fraction of the circumference by an arc is the fraction of the angle to a whole circle angle, which is 2 pi.
Right. No, but Seth, I beg to disagree with you. I would not.
Well, you can beg, but
okay,
you can beg for the right answer. And go ahead.
Come on. But first of all, I would not consider areas pi r squared as a theorem. That is a formula. Formula for the area.
It's a theorem.
Fine. But you said only one theorem, and you chose this one. No. This is the circle theorem. Pi radius times the angle in radians is equal to the circumference of the arc. That's a circle theorem. But guess what? That may not some people may not have been taught that.
Well, they should have been.
Well, okay.
What can I say?
They should have been, right? But it's possible they were not. Now that is should we clear everything? Yeah, I guess so. So that is an important circle theorem, that the measure of an arc, the measure of the arc, the circumference of an arc is equal to the length of an arc. The length, arc length. Oh wow, look at that. Arc length, which is the technical word, is the radius times the angle subtended by the arc, but this has to be in radians. The problem is that may not have been taught to some people.
Well, they should have been taught.
Right. Oh,
and this test is a test of whether it was.
So we're definitely going to want to look at the answer to see whether the SAT will require you to know this. And this will be based on the answer that Khan gives. If Khan uses this theorem,
let's see what they said.
Then you have to do it. Now, I do want to say how to do it without using the theorem, using ratios. because make that clear. If you don't have this theorem, this really is a ratio problem. And what it really is the ratio of ratio of this sector to ratio of this sector to the whole circle is the ratio of pi times 10 is equal to 75 divided by pi 10 squared, because 10 squared is the ratio of the whole circle. Ratio of the sector is ratio of the sector to the whole circle is 75, because that's the area to the area of the whole circle. Okay, now that's the ratio. It's the same ratio of what the answer is to 2 pi times 10. Now we have a problem there because x there. We have a problem there, don't we?
Same thing, same answer.
You're saying that it goes like that, right? Right. That's right. Yes. We're setting the ratios. The ratio of the area to the whole circle equals the ratio of the sector to the whole circumference of the whole circle. So that's
yeah.
Now,
actually, it's
so this
this X thing you put there.
Yeah.
Sure. The X thing is the answer.
Right, exactly. So
we're doing
it strictly as a ratio problem.
Okay? Yeah, that's a good idea. That's better. Yeah.
That means
strictly as a ratio.
So now we will see which
so the
way
ratio, the area ratio is the same as the length of arc ratio.
Right.
That's a very good intuition. Yeah. So the principle there, you have a all right.
Now this principle comes up a lot. This is a major principle that
don't draw arrows. That the ratios of these guys the same as the ratio of the areas.
That's right. But this will save you on a lot of problems. And these problems sort of have the same feel. Go as a ratio. So let's see if you solve this thing. You cross off the pi's, which is very nice. Oh, this 10 crosses off with this. Oh, yeah. So you have 75. Wait. There's 2. This 2 crosses off with the 5. So 75 is 5x. X is 15. So we get the same answer. Just want to solve the ratio problem for everyone just to complete that. So drum roll. Which way is it? Which way is it? Using the arc length theorem that Seth says? Well, Seth doesn't say
of course, they're equivalent, but more details were written out the way I did it, and I think your way is more elegant.
Really?
Wow, I prefer your way, yeah.
Thank you. That's a super compliment.
Okay. Yes, it is.
So let's see. Yeah. Okay, so let's see. Drum rolls. It'd be very interesting to see. And if they use R theta, you got to know R theta for the SAT. 15. Do we need units? No, we don't need units. Okay.
They didn't give units.
Yeah, it's fine. Oh my God, we got it right. Well, we both agree to the answer. Who knows if hopefully we're both right. Okay, let's see.
What?
Okay. Ooh, look at this. This is major big time knowledge for people. The SAT is expecting you to know this formula. So if you don't know it, this is the time to learn it. Okay? Because anyway, the area is this. Okay, fine. Yeah. They said it sort of the way you did it, didn't they? The area. Oh my God, the formula for the area of a sector is that 1/2 theta times r squared. Wait, that's such a weird. I've never even seen it written that way.
Yeah.
Now theta is equal to 2 pi.
When for the whole circle, a whole circle that gives theta equals if the area of the whole circle is say 1/2 of 2 pi r squared, which gives the usual pi r squared.
Maybe
Well, it's
maybe in calculus. Maybe in calculus you do this because calculus is really into athenas and radians.
They boldly give you this formula, and my teachers never told me to memorize this
I don't
formula.
think I've. Boy, the last time I may have seen that formula was in polar coordinates and calculus, which is way above the SAT. Maybe.
The way this comes from, I'll talk about the idea of this formula.
No.
This formula, if this gives, when the angle is small, this tiny sector is like a triangle, and its area is 1/2 of the base times the height.
So don't go
And
there
the
now.
and the base is the length of the base is the height times pi, because of the measurement of pi times the angle, pi times the angle. So this is the angle. The length of the base is approximately the angle times the radius, which in a tiny, skinny triangle is approximately the height. So that's where it comes from.
Who cares where it comes from?
But again, who cares? It's an interesting formula. A lot of mathematicians care about formulas like that.
But who
You
cares
may
about
not, but it's still. But somehow they pulled it. They pulled it out of the hat.
Nobody learns this. Nobody learns. Very few people. And this is not traditionally taught in high school. So how did that? It's weird
we don't
that they're
remember it in
expecting
high
that.
school.
What?
Yeah.
It's weird that they're expecting you to pull this out of the hat from high school. Yeah, you're a mathematician, fine. But these are high school kids.
I know, yeah.
So, okay, the bottom line is the SAT, through the SAT, is wanting you to know this formula, okay? So you...
Well, is the top formula one of the formulas they give you in the test?
No, they don't give you that formula.
Yeah.
No.
Okay.
No, okay, anyway, so they're doing it... Wow, this is a strange way. You have to start with this formula. If you don't know this formula, you can't do it the way they're doing it.
Yeah.
My suggestion is when you have sector problems, they're just ratio problems.
It depends on the data that's given.
It's rare to see a sector problem that can't be written as a ratio problem because a sector is part of a circle.
Mm-hmm.
You can usually recast it always as a ratio problem if you don't know the formulas. If you know the formulas, it can help a little bit. Of course, I helped the formulas before, and when I first started doing the question, I was doing it all wrong. But then I caught myself and said, "Oh, this is a ratio problem." I don't even know what did they do here. What is this?
Mm.
So, what did they do? Wow. Oh, they calculated the answer in radians. They actually got the answer in radians. Okay.
Yeah, the angle of 1/2 radian.
It's very nice to do it this way.
Which is certainly.
Yeah, if anybody's watching this, can you please comment and say, "Oh yeah, I was taught this formula." This one. We'd love to know.
So it's indeed it's not to scale, but the angle is pretty close to a quarter circle, is it?
Well, okay.
15, 1.5 radians. No, a whole circle. A whole circle like is 2 pi radians.
Yeah.
Which is approximately 6.25.
Right.
Which is approximately, 6.28.
6.28, yeah.
And so this angle is a little bit less than a right angle.
Yeah.
But it's indeed, people will be dissuaded. No.
Yeah.
No, we cannot assume from the picture that this is a right angle.
Absolutely right. That's another thing in geometry. You cannot assume anything. You have to only do what
Even
you are
though it
told.
sure looks like a right angle.
Yeah, yeah, yeah. Don't be
It
deceived by
probably
that.
is a right angle. It's so it's not just scale. The scale not just is the scale is wrong, but the aspect ratio is wrong.
Mm, yeah.
The thing is squeezed,
Mm,
right? It's squeezed and rotated.
yeah, 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 yeah.
Yes.
So, I mean, in geometry, you never assume anything unless you are
Yeah.
told. You're not allowed to do any of that stuff. Wow. Okay, so I don't think we should move on to the second question. We should leave the next 9 more
Leave
because
this in
this
peace.
leave this in peace, right? I sort of crashed at the beginning. I sort of caught myself. Seth did it. Well,
Mm.
Seth did it similar. Well, not really similar, but he set up the ratio, set it up the by knowing the S is equal to R theta.
Mm.
I did it as a ratio problem. So, suggestion for approaches to study. Well, first of all, you can't get to the 11th question unless you've gone through 1 through 10 yourself. Those are the first 2 little things in this little thing. So you should go ahead and do those 10 yourself and then start moving into the more complicated, harder questions. Okay, so I guess that's it. Tomorrow's Throwback Thursday, which is nice. We do a question from the tests that predate 2016. I guess that's it, right? I guess that's it. Okay, how's the weather? It's a little cool today, isn't it?
Yeah, yeah.
Yeah, that's nice. Yeah, but it's still a beautiful sunny day.
Yes, it is.
Nice and cool and sunny. Okay, everyone, have a great
All
day.
right.
Take care. Bye bye. Okay, let me stop that. Stop the share and stop the recording.
Mm.